Welcome back, everyone, to another College Algebra lecture. Today, we are going to continue on talking about polynomial functions and focus in on the real zeros of a polynomial function. Now, I mentioned real here because there are two types of zeros that we're going to deal with. Today, we're talking about real zeros. Next time, we'll talk about complex zeros, and each one is special in its own way. Now, what's special about real zeros is that these are where our graph crosses or touches the x-axis. And that matches exactly with what we did last time. Last time, we looked at graphs and we saw where we crossed or touched the x-axis, and that wound up being a zero for us. Now, you might be wondering, why are we having a lecture over this when I can just find it in my calculator easily like we did last time? Well, sometimes the zeros that you have for a polynomial aren't something that you can see easily on the calculator or whatever graph you're looking at. Unless it's a whole number, normally you can't get an exact value by looking at a graph. But today, we're going to figure out how we can solve it algebraically and get a good closed form answer for every zero that we're looking for, as long as it's real. Now, before I can get you into the primary techniques for what we're going to use, we have to talk about synthetic division, because this is a very powerful tool that we are going to use in order to find our zeros. So for synthetic division, this goes kind of similar to polynomial long division, but it's a lot faster and a lot easier. Now, when we're talking about synthetic division, you're going to see problems that look kind of like this. You're going to have the polynomial that you're dividing into, which is called the dividend, and then you'll be dividing by a linear term called the dividend. Now, the divisor and dividend, you don't have to memorize those terms. I'm not going to call them by that. So what's special about synthetic division is you can only divide by a linear term, the ax plus b, which that's all we're concerned with, so it's always going to work. All right, so before you go in and start trying to divide, there's two things you always need to check in regards to what you're dividing into. You first have to make sure that it's written in standard form. So if you remember, standard form is descending order for the exponents, biggest to smallest. So example up here, this one is not written in standard form because that 5x to the fourth should be first. So this is now in standard form. So that one's pretty easy to spot. The next piece, though, this is very, very important and easily missed. Any exponent that is missing for an x, you have to fill it in with a 0. So what I mean by that is, looking at this right here, I have exponent 4, 2, 1, and none. Well, I have to fill in x to the third, which is missing right here. All you have to do is just fill it in with a 0. Once you fill it in, it's pretty easy to make sure you have everything. Just do a little bit of a countdown. 4, 3, 2, 1, none. Always start with your biggest. You don't need to add any zeros ahead of that. Start at your biggest and count down. Everything should be there. That is super, super important. And if you miss that step, things are going to go sideways really quick. All right, so let's talk about how you can do synthetic division. Now, I'm going to talk you through all the steps, but just in case you can't remember a certain step that I said and you can't figure it out by looking at the example, I typed up all of the steps right here for you. So don't worry about having to write down the steps. They're all listed right here. Just learn the process. All right, so synthetic division, what makes it so easy is that we are not going to include any x's, plus signs, anything like that in this. We are only going to deal with numbers. And to start with, we're going to look at what we're dividing by. So here I'm dividing by x minus 2. What I'm going to do is I'm going to set that equal to 0, and then I'm going to solve. That gives me x equals 2, which that should be kind of a straightforward thing to do, because normally we're always concerned with the zeros of a function. X equals 2 is the 0 of that little one. So that works out pretty well. This 2 is the number that we are going to divide by. So now I'm going to set up my division box. The division box looks like a really big L. So just like that. What we are dividing by here is the number 2 is going to go on the outside in the top corner. So whatever you divide by goes out here. Now the numbers that we're dividing into will be up here. And the way we get them is they are the coefficients in our polynomial. The coefficients are the numbers in front of the x's. So right here, I first have to make sure everything is there in the right order. Doing my countdown, I start with 3, 2, 1, none. Everything's there and in the right order. So to list out my numbers, 2 is first, because that's my first coefficient. Then -5. Negatives are the only extra symbol we have to include. Then I have 3. Then I have 7. Those are all of my coefficients. All right, so our division box is set up. Now we can actually start on the division itself. The very first step when you're starting on the division is you're going to take the first number on the inside and drop it straight down. I encourage you to draw the arrow to help you remember that's what you're supposed to do. So I'm going to write it here under the box. Then I'm going to multiply. I'm going to multiply the number on the outside by the number on the bottom. So 2 times 2 is 4. That 4 gets written down inside the box under my next number. So I want you to notice it follows a check pattern. When I go sideways, I multiply. 2 times 2 is 4. Looks like a check. Next, these two numbers, I'm going to add them together. So -5 plus 4 is -1. So whenever you move down, you add. And the same thing happened right here. There's an invisible 0 that you can't see. So 2 plus 0 is 2. So every time you move down, you're adding. Now you just rinse and repeat. 2 times -1 is -2. Then you add these going down. 3 plus -2 gives you 1. Next, I'll do it again. 2 times 1 is 2. Now I'll add going down. That's going to give me 9. Done. We are finished dividing. There's nothing else to do for the division step. Now we just need to write our final answer. Well, for the final answer, we have to bring the x's back in because our original had x's in it. It's a polynomial. I can't just say 2, -1, 1, 9 and be done. So to bring the x's in, you need to follow this pattern. Always start on the right side, and you're going to label that R. Then after R comes C, and from C we'll do X, and now we count upwards in X. So after X comes X squared. The square has nothing to do with that 2 right there. If I had another number right here, that would be X to the third, then X to the fourth, and the fifth, and sixth, so on. So after C, you just start counting up in X. Now the reason we did this is because this is my first term, 2x squared. My next term is -1x, which is just going to be -x. Then the C stands for constant. The constant is the term that does not have an x on it. So this will be +1, plus because it's positive. Now for the last one, the R. R stands for remainder. And if you remember learning long division whenever you were growing up in grade school, you'll remember that for remainders, you're supposed to write them as a fraction. So it's going to be a fraction here also. This is going to be plus because that's a +9. I'll say 9 divided by, don't put 2, even though that's the number we divided by here. What we originally divided by was x minus 2. So that's what I'll put right here. That is my final answer. So after I divide this polynomial by that polynomial, this is what we get. And we're done. That's synthetic division. And the more you do it, the faster it gets. Drop the first one down, make multiplication with the check going across, add going down, and then just repeat. So the more you practice this, the faster it gets. The only thing that can be a problem is if you don't have a calculator and you get some big numbers. That's it. That and if you miss filling in a 0. All right, so that's synthetic division. Let's practice a couple more on the next page. All right, so I'm going to put several on here. If you're comfortable after the first one, skip ahead to the end of this page. Don't go on to the next page because there's something special I got to show you. And it goes with this little theorem up here. But before we do the theorem, I want to show you some more problems because it'll make more sense afterwards. So for the first one, I'm going to divide this polynomial by this x plus 2. So solving this right here, this would give me x equals negative 2. The way we get that is I would set it equal to 0, subtract the 2, there we go. So what we're dividing by is negative 2 on the outside. Now, set up our division box. Check to make sure everything is there. I have 3, 2, 1, none, everything's there. The number in front of x to the third is 1, and then 3, 2, negative 1. All done. So at this point, we can start our division. I'm going to bring down my first one. Now we multiply. Negative 2 times 1 is negative 2. Now we add. 3 plus negative 2 is 1. Now we do it again. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. Negative 2 times 0 is 0. And that gives me negative 1. Done. There's nothing else to do. Now, to turn it back into our final answer, I'm going to label them. So always start on the right side. Right starts with r, then c, then x squared. So my final answer here is x squared plus x. Since this is 0, I don't have to put it. And now I'll have minus 1 over x plus 2. And that's my final answer. All done. So hopefully you're seeing that these will be pretty quick as long as you remember the process. All right, now for the next one. Right here, we're going to solve this one, set it equal to 0. Doing so, we get x equals 1. All done. So now I know 1's on the outside. I'm going to check to make sure everything's there. 4, 2, 1, none. I'm missing the 3. So right here, I'm going to fill it in. I have 0x to the 3, or x to the third power. Now, 4, 3, 2, 1, none. All right, so I filled in my missing 0, and this is all you need to do. Just put a little arrow somewhere. You don't have to rewrite the whole thing. Now, filling in my numbers, I'm going to start with negative 3. Then I have 0. Then I have negative 4. Then 6. And then negative 5. Got it. So going through our synthetic division, we drop the negative 3. That 1 times negative 3 is negative 3. Add that to 0, we get negative 3 again. Now negative 3 times 1 is negative 3. Add those together, we get negative 7. I get negative 7 here when I multiply those two. Add those, I get negative 1. Multiply again, I get negative 1. And that gives me negative 6 when I add. These get really fast. Multiply across, you put the number down, add, and then do the same thing. Now that we're done with the synthetic division, we can label. Always start on the right side, which starts with r, c, x squared. Now I have x to the third. And we can write our final answer. Final answer, negative 3 x to the third minus 3 x squared minus 7x minus 1 minus 6 over x minus 1. All done. There's nothing else to do. All right. So hopefully you're feeling pretty comfortable with these. I do want to do 2 more, but if you're comfortable so far, go ahead and skip to the end of this page. All right, looking at the next one. I see that what I'm dividing by is going to be x equals negative 2. And now, doing my countdown, 3, 1, none, I'm missing the square. So I have 0x squared. Alrighty, so I have -2 on the outside. On the inside, I have 5, 0, -8, and 7. And I'll start going through these a little faster. So I drop my 5. -2 times 5 is -10. Add that to 0, we get -10. Multiply that by -2, I get 20. Add that to -8, I get 12. Multiply that by -2, I get -24. Add that to 7, and I wind up getting -14. Done. Nothing else to do. Not -14, that's -17. My bad, I can do math. Yeah, 17. So that's going to be r c x squared. So my final answer, 5x squared minus 10x plus 12 minus 17 over x plus 2. Got it. Nothing else to do. All right. Now for my next one, this one has a cool little thing to it. We'll start the same way. I know I'm going to be dividing by x equals 4. So I have 4 on the outside. For my division, 4, 3, 2, 1, none. Everything's there. So 2, -7, -8, 14, and 8. All right, so now I will drop my first one down. 2 times 4 is 8, plus -7 gives me 1, times 4 is 4, plus -8 is -4, times 4 is -16, plus 14 is -2, times 4 is -8, plus 8 is 0. So hopefully you're getting a really good handle on synthetic division. It goes pretty quick. Now labeling, we have r, c, x, x squared, x to the third. So writing our final answer, I have 2x to the third plus x squared minus 4x minus 2. Well, here my remainder is 0. If it's ever a 0, you don't have to put it. So this is my final answer, which this is another polynomial. I get this one. I know it's a polynomial because I don't have any negatives or fractions in the exponent. All these other ones have not been polynomials because this doesn't count. If I'm ever dividing by an x, that's no longer a polynomial. So the only one that gave me a polynomial out in the end was this one. All right, so hopefully you're feeling pretty comfortable now with synthetic division. Let's go back up and look at this top property. So this property says that if f of x is divided by x minus c, which is what we've been doing, and has a remainder r, whatever number it is that we label r, then that remainder is the same thing as if we plugged what we divided by into the function. Now, that might not make a whole lot of sense in words to you. That's why I want to do these problems first. What this is telling us is right here. The number I divided by was -2. If I were to plug in -2 into my function like this, f of -2, what I am guaranteed to equal is my remainder, -1. Done. So right here, I divided by 1. So if I were to do f of 1, it's guaranteed to equal -6. Now you might be wondering, why do we care? Why is this important? Well, imagine you're having to take a difficult math test, say like the SAT, and this is a question that's on the non-calculator portion. Well, if you were asked to evaluate, let's say, f of 7 for this polynomial, that means you would be raising 7 to the 4th power, 7 to the 2nd power, then multiplying it by something, then adding them all together. It gets ugly really fast. But what you could do instead is synthetic division. Divide by 7. This takes about a minute, and then whatever you get at the end is what the whole thing is equal to, which makes your life way easier as opposed to having to put it in here and raise it to exponents. So that's one benefit of it. The other benefit is down here if we look at D, which before I do that, I'll go ahead and fill this one in for completion's sake. I would do f of -2. That gives me -17. Now, right here, this is the one that's special. This is the most important one. If I were to evaluate at 4, f of 4 is equal to 0. That's special. This means that x equals 4 is a 0. Because remember, our other definition of a 0 is it makes the entire function equal 0. So we just found a 0 for this polynomial without even having to look at the graph. So that's a very special thing, and that's the reason we have to use this tool to solve for everything else. All right. So before we go on to the next page, I do want to mention one other thing. Right here, when I did my synthetic division using a number that wound up being a 0 for me, I got a polynomial out. So that means since this can divide it, that means it's a factor. Anything that can divide something is a factor by definition. So x minus 4 is a factor of this one. And after I factor it out, this is what's left over. So kind of that means that this would be in parentheses, that would be in parentheses. That's a way to factor. That's what we're about to do. So looking at the next page, it is the factor theorem. So the factor theorem says that if f is a polynomial function, if x minus c is a factor of f of x, or it's a factor if and only if f of c equals 0. That's basically exactly what I just said on the previous page, just in different language. If you can divide by that number and you get 0 out, that means that x minus that number, c, is a factor. Now, if this still isn't jiving well with you, let's look at an example, and it should hopefully make more sense then. All right, so for these two examples right here, what I want to do is just see if the linear term is a factor or not of the polynomial. All right, so to see if it's a factor, that means I should get 0 for the remainder when I do synthetic division. That's what's special. All right, so looking at this one right here, I see the number I'm going to divide by is x equals -3. It's always the opposite sign when we solve. All right, so doing our synthetic division, I have -3 on the outside. Check to make sure everything's there. 3, 2, 1, none. We have everything there. So 1, 2, -5, and -6. Now doing our division, I will drop my first one down. And then -3 times 1 is -3. Add that to 2 and we get -1. -3 times -1 is 3. Add that to 5, we get -2. -3 times -2 is +6. Add that to 6, we get 0. Now I can do this r c x x squared. Since my remainder is 0 right here, that tells me that x plus 3 is a factor of f of x. That's how you test. If the remainder is 0, then what you divided by is a factor. Now, if you're not sure what that even means, This is what I'm talking about. I would have x plus 3 right here, and then I would have 1x squared minus 1x minus 2. This is the factored version of this big one. And you can go back through and distribute and double check. X times x squared, x to the third. And then 3 times negative 2 is my negative 6. And then you can finish the rest of it to figure out the middle. So I factored this big one into this small one. That's what it means to be a factor. Now, the reason this is important to us is because now I can factor this. This is one I can use the ABC method on easily. So doing my ABC method on the smaller one, I have a times c is negative 2. My b is negative 1. The two numbers I could use, 1 and negative 2. So now I can take that big polynomial that was to the third power and break it down even more. Plus 1 minus 2. So by knowing one factor, I was able to find all three factors. That's the power of this theorem. And to finish it out, I now know that there are 3 zeros for this one. Negative 3, which we already knew because the remainder was 0. And then right here, negative 1, and then positive 2. We found so much information just based on the fact that x plus 3 is a factor. That's what we're going to do for pretty much the rest of the time. All right, let's try it one more time. I want to see if x plus 1 is a factor of this one. Let's see if we can write it as 2 parentheses touching. So I see what I'm going to divide by is x equals negative 1. So right here, doing a countdown, 3, 2, 1, none. Everything's there. So I have 1, 8, 11, negative 20. Now doing our stuff, we drop that straight down. So 1 goes right here. Negative 1 times 1 is negative 1. Add that there, we get 7. 1 times negative 1 times 7 is negative 7. Add that, we get 4. That gives me negative 4 when I multiply those, and negative 24. That's r c x squared. Well, this isn't a polynomial because I have a remainder. So since it's not a polynomial, x plus 1 is not a factor of f of x. And that's it. I can't write it as 2 polynomials touching inside parentheses like I did up above. And you just stop right there. We only care about ones that have 0 for the remainder. That is it. So hopefully it's going pretty well. Big thing on here, if the remainder is 0, that means what you originally divided by is a factor. The reason we know it's because it equals 0, I could solve this one and I get 0. What's left over is a polynomial, so I can put that in parentheses, and then I can factor that one and find all the rest. All right. Now, you might be wondering, oh, this is great and all. I can figure out if something's a 0. But so far, we've only done this with me giving you the stuff to divide by. Most of the time, I'm just going to give you a polynomial and just say, hey, find the zeros. We haven't done that yet. I've given you a polynomial, and then I've given you something to divide by. Going forward, you're going to have to figure out what you're going to divide by on your own. Well, good news, there is a way of listing out possible answers. Now, I will go ahead and tell you ahead of time. This part right here, I will never make you do. Because for our class, you do get to use a calculator. And as soon as you get a calculator, this step right here goes out the window. This step is extremely useful if you do not get the use of a calculator, which there are courses that don't get to use one. But for our school, they let you use a calculator for this class, so you don't have to worry about that. But just in case you ever have to take this type of material again somewhere else, or do it on an SAT where you don't get a calculator, I want to show you what to do. And I'll only do one of these because I don't particularly care for this that much. So what we're going to talk about is the rational zeros theorem. Now, the rational zeros theorem basically in a nutshell says that if your polynomial has a zero that is rational, which means that it could be a fraction, could be a whole number, could be a negative, as long as it can be written as a fraction or a whole number, positive or negative, it will guarantee to be of a certain shape. What's special about it is the numerator, which here is p, will be a factor of your constant term, and your denominator will be a factor of your leading coefficient. That's what's special. So if your polynomial is going to have a rational zero, then it will be of a certain shape. All right, now how is that useful for us? It gives us a starting point. We can list out some possible zeros, and that's what we could use for our synthetic division to make our polynomial smaller by factoring. But downside is sometimes you have a lot of zeros that you could possibly get, and there's no guarantee that any of them even work. So I want to show you this once. I want to list out all the possible rational zeros for this one. To start with, I'm going to identify my leading coefficient. Here, it's 3. And then I'm going to identify my constant, which is negative 12. The next thing I'm going to do is I'm going to list out factors. So I'm going to do a little extra step right here. So I have factors of my constant divided by factors of the leading coefficient. All right, so my factors of my constant, I have 1, 2, 3, 4, 6, and 12. And then for the denominator, my factors of my leading coefficient 3 are just 1 and 3. Oh, but wait, there's more. Right here for 3, that could be 1 times 3, or negative 1 times negative 3. So that means each one of these could be positive or negative. So there's 4 potential factors on bottom. And up here, same situation. Each one of these will be plus or minus as well. All right. Now, the next step you need to do is go through and list out the different combinations of these. The way I recommend doing this is start with just a single denominator or number for the denominator and then change the numerator. Now, I'm going to leave the plus or minus off until the end. So I could, if I start with 1, I could have 1 over 1. Then I could have 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. Now that's everything that could have 1 on the denominator. Now I have to do it again with 3. I have 1 over 3, 2 over 3, 3 over 3, then 4 over 3, 6 over 3, 12 over 3. And I understand some of these reduce. I'm doing it this way to list out all the possible ones and keep track of what I have. I do another step afterwards where I bring the plus or minus back in, and then I reduce. So 1 over 1 is just equal to 1. So I have plus or minus 1. Everything over 1 is just going to be itself. So plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now for these, I have plus or minus 1/3, plus or minus 2/3. Well, 3 over 3 is 1. That's already on my list. I don't need to do it again. Then plus or minus 4 over 3. 6 over 3 is 2, already on the list, done. 12 over 3 is 4, already on my list, done. So now I've listed out all of the possible rational zeros here. Now, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 18 because they're positive and negative. Now, if you haven't already picked up on this, I'm not a big fan of this theorem just because you have 18 possible answers. Only one of them might work. Or worse yet, none of them might work. You might not have a single rational answer. This one, I can tell you that there would be, but it would be awful. You would have to go through and try and just hope that whichever one you pick to do synthetic division with works on your first attempt. You might have to do this 18 times before you find the right one, which is just awful. It's awful. So is this tool powerful? Yes, it's extremely powerful. And if you're lucky, it's great to use. But if you are allowed use of a calculator, I highly recommend bypassing this. And I'm going to show you how. All right, so we're not going to continue on and do the second one. That was enough. All right, moving on. These are the primary problems that you're going to see. And this is what we've been building up to. I know, it's been a lot of buildup for just certain type of problem, but there's a lot to learn. So what we're going to do is we are going to figure out all the zeros for a polynomial function. And I gave you steps on how to do this. Now, step one, I'm kind of cheating. I have not taught this theorem to you yet. It's what we're going to do in the next lecture. But what you need to know is the most number of zeros that you're going to have is equal to your degree. So the maximum number of zeros that you could possibly have will be equal to the degree. So looking at this one, I know I can have at most 3. And there's a little bit more detail to that I'll fill in next time. But for what we're doing today, the most you will have is at most 3. Now, right here, step 2. Step 2 is what's going to allow us to skip the rational zeros theorem. And trust me, once you see how to do it, you'll be grateful that you get to use a calculator to skip that step because it's going to save you a lot of time. All right, step 3, we'll use the zeros we found in step 2 for synthetic division, and then we'll solve whatever is left over. All right, now I keep telling you that we can skip the rational zeros theorem. Now's the time for me to show you how. What I want to do is find all of the real zeros for this one. Well, if it's a real zero, that means we cross or touch the x-axis. Let's find those. The way we're going to do it is whatever graphing utility you have, whether it's a calculator or if you're using Desmos, which is a really good free online graph, just type it in. So here, I'm going to put this in. I'll have 3x to the third plus 8x squared minus 7x minus 12. Always double check to make sure you did it in there correctly. All right, everything's there. Now I'm going to look at the graph. So looking at this one, I see that I crossed through the x-axis 3 times. So I know I have 3 zeros, which is great. But looking at this, it looks like I have one right around -3. Looks like I have one at -1. And this one looks like it's close to 1. Do not write all of those down yet, because it's not guaranteed that those are true. What you have to do is make sure that y equals 0 for the table. So here, there's a table I can look at. If you're using Desmos, you can just hover over the x-intercept and it'll tell you what the value is. So looking right here, I see when x is -3, my y value is 0. That worked. When x was -1, my y value is 0. That worked. However, at 1, our other guess, that did not work because my y value was not 0. So I cannot say that x equals 1 is a 0 for me. The only two I know for sure are -3 and -1. So I'll write those down. I know x equals -3 and -1. And just so you remember what you're doing, if you look back at the notes, found using a graph and y equals 0. So we look at the graph, whether we cross or touch. So for the graph, here you go, little extra note, cross or touch, and then verify that y equals 0, whether it's in a table or hovering over it. This is very important. All right, so I have those two. This means that I can do synthetic division 2 times, which will make my life pretty easy. Now, you could just do synthetic division once and then solve using factoring, but I'm going to show you that you can do synthetic division twice. So right now, I'm going to start with -3. Which one you start with doesn't matter. So making sure everything's there. 3, 2, 1, none. Everything's good. So I have 3, 8, -7, and -12. Now, if you notice, this is the same one from the previous page. I didn't have to list out all the possible zeros because I found that using the graphing calculator. That was one of the potential ones. And it's definitely not the one I would have chose first. I usually like to start with the positives. So I'll drop that down. So I have 3. That gives me -9. -1 right here. That gives me 3. -4. 12. 0. All right, now for a really cool little thing. Since we know that these are guaranteed to be zeros, we found that in the calculator. We know that to be true. Since they are guaranteed zeros, we know that the final answer is guaranteed to be 0, just based on our first theorem for today. If you ever find these in the calculator and you know for sure those are true and you don't get 0, you messed up your synthetic division. All right, now for the next cool part. I can do synthetic division again. If -3 is a 0 for all of this, that means -1 is going to be a 0 for what's left over. That's kind of like that previous page where I broke it down into 3 different factors. So I know -1 works for this one. So I'm going to do synthetic division again. And instead of doing with the original, I'm just going to do it with these. 3, -1, and -4. I can leave the 0 off. So dropping 3 down, I have 3, -3, that's -4, that's 4, that's 0. Done. Now, at this point, I don't have any more zeros that I can do synthetic division with, so I'll label R, C, and X. This is our missing factor. So I will write this down just this time, but just so you know what's going on, this is a factor for us. So this would be parentheses x plus 3, because remember, we got to move it back over. This is a factor. Moving it over is x plus 1. This is the missing factor, 3x minus 4. This is the fully factored version of that one right there. These two came from the zeros that we found. This came from the synthetic division. So as far as finding all of our zeros now, I can do this. X equals, I know -3. That's going to be -1. Solving this one, 3x minus 4 equals 0. Oh, sorry, can't see that. I would move the 4, divide by the 3. There's our final answer. That was the missing 0 for us. Now, did you need to write out the factors like this? Absolutely not. You could have went straight from here to writing that out and solving for it. But I wanted you to see what's going on behind the scenes before I skip that step. By finding these zeros in our calculator, I knew those were factors. I used synthetic division twice to find the remaining factor right here. Then these we already had. I solved that one and found my missing zero. That's it. So do synthetic division as much as you can in order to find all your zeros. It makes your life way easier. All right, so what we're going to do for the rest of the time is just work on problems like this. Now, if you think, oh, I'm good after that one, I don't need to do anymore, the last page has a couple of special ones on there that I want you to see. All right, so let's do this again on this one. We're going to start the same way. I'm going to take my polynomial and I'm going to put it in my graphing calculator. So I'll do 2x to the third plus 15x squared minus 47x plus 30. So looking at this one, I see that I have 3 zeros. I cross over here, and then I cross and I cross again. So this one, counting over, is negative 10. And one of these looks like they're 1. So I know I have 2 for sure, and another one looks like it might be somewhere else. So double check. My guesses are negative 10. The y value is 0. It worked. And again, if you're using Desmos for this, that's even better because you can hover over the intercept and it tells you the x value and the y value for sure. So negative 10 worked for sure. My other guess was 1. 1 worked, but that other cross right around that area doesn't show up on here. So I know 1 worked for sure. This means I can do synthetic division twice. So I'll start with negative 10. So start with negative 10, 3, 2, 1, none. Everything's there. I have 2, 15, negative 47, and 30. Now, dropping that one straight down, that's going to give me negative 20. That's going to give me negative 5. That gives me 50. That gives me 3, negative, and 0. Everything worked out great because I ended with 0, just like we knew we would. If it's guaranteed to be a 0, that's guaranteed to be a 0 there. Now I can do synthetic division again using 1. So I have 1 on the outside. And now I'll just use the numbers I had left over. 2, negative 5, and 3. What I'm doing now is I'm factoring this polynomial using 1. So I'll drop that. That gives me 2. That gives me negative 3, and 0. Got it. Now I'm out of x's that I can use that I found. So that's r, c, that's x. So now instead of writing out all the factors, I'm just going to solve this one. That's 2x minus 3. And I want to find the 0 for that factor, so I'm going to set it equal to 0. Move the 3. Divide by the 2. And I get x equals 2 over 3. I skipped writing out the factors and just went straight to solving this remaining factor itself. So my final answer, all of my zeros, I have negative 10, 1, and 3 over 2. Quick and easy. Synthetic division works really fast. And as long as you can use a calculator or some graphing utensil to find those, your life is easy. If you don't and you have to use the rational zeros theorem, I wish you the best of luck finding the 0 on your first try. All right, now for the next page. For this, there are 3 examples, and for each example, I bring in something special for each one. All right, so what we're going to do is start the same thing. Looking at this one, I'm going to type it in. So I have 2x to the fourth plus 3x to the third minus 24x squared minus 4x plus 48. Okay, I see 2 crosses and 1 touch. So right here, I see that I cross at, looks like it's around, what, -4? This one's definitely between 2 numbers, so it's not going to be on my list. And then right here, this one looks like it touches at 2. So -4, it worked. 2, it worked. That was it between them. So I know that I can use -4 and 2. Now, if you're wondering, like, hey, it touched at 2, that means something special because we learned that last time. You're right. That does mean something special. But I want to show you an alternate way of going about these that doesn't involve you remembering one special little trick rule. So I know I can do synthetic division twice. So doing synthetic division twice, I'll start with -4. So I have -4 on the outside. Counting down, 4, 3, 2, 1, none. Everything's there. I have 2, 3, -24, -4, and 48. Drop the first one. That's 2. That's -8. That's -5. That's 20. That is -4. That's negative. Oh, no, that's positive 16. Sorry. That's 12. That's -48. That's 0. Got it. It ended with 0, just like we knew it would. Now I can do synthetic division again. I'll put 2 on the outside. Now I have 2, -5, -4, and 12. 2. That's going to give me 4, -1, -2, -6, -12, and 0. Got it. See how fast synthetic division is? I keep trying to sell you on it. I like it a lot. It's one of my favorites. Now, I've run out of x's to use. So at this point, I'll label. That's r, c, x, x, x squared. So now what's left over for me to solve is this. 2x squared minus x minus 6 equals 0. Well, that's not as easy as the previous one, but we can at least use the ABC method on this one. Now, first thing to notice is our a equals 2. That means divide and swing. So divide and swing. All right, so a times c is going to be -12, and our b value is -1. So the two numbers that I could use here, I see that I could use 3 and -4. All right, so writing out my factors, I have x plus 3, and then x minus 4 equals 0. And now we divide by our leading coefficient 2. Alrighty, so right here, this one won't reduce, so I'll swing it over. I have 2x plus 3, and then this one is x minus 2. Perfect. So now I can list out my answers. For this one, I would subtract the 3, divide by 2, and I get -3/2. Right here, I would do that, and I get x equals 2. But wait, that was already an answer for us. We knew x equals 2. What this means is x equals 2 has multiplicity 2. That should make sense because if you have an even multiplicity, you touch, you bounce. So really, I could have done synthetic division twice using 2. I could have done it on this one using 2 again and wind up with just this last linear term. But that's kind of tricky to remember. So I'd much rather you just think of, use the ones that you see, and then solve whatever you get left over. Here you had to do factor, but we know how to factor. So our final answers on this one, we knew x equals -4, x equals 2 with multiplicity 2, but I don't have to write that, and then -3/2. So the trick on this one, if you touch, that means you could do multiplicity 2 and use synthetic division twice. But it could be multiplicity 4 or 6 or anything like that. So don't worry about that. Just solve using factoring. All right, now for the next one. So looking at this, we're going to go about it same way as usual. So put it into whatever you are using for graphing. Squared plus 3x plus 60. All right, so looking at this, I see that I cross 4 times. So that means I will guarantee to have 4 real zeros. This one looks like it's around 1, 2, -4. This one looks a little off. It looks close to -2, so we can check it. This one looks close to 2, so we can check that. And this one looks like it's around 1, 2, 3, 4, 5. So my guesses are -4, -2, 2, and 5. -4, it worked out. So I know for sure that x equals -4. 2 did not work out. I don't have 0. 2 or -2 didn't work. Now 2 doesn't work. So my last guess was 5. That one worked. So this means I can do synthetic division twice. Okay, so starting with -4, I have -4 on the outside, filling this in. 4, 3, 2, 1, none. Everything's there. So I have 1, -1, -23, 3, and 60. Drop that down. So that's going to be -4, -5, 20, -3, 12, 15, -60, 0. Everything worked out just like we knew it would. Perfect. Now we can do synthetic division one more time. So I have 5 on the outside. And now I have my numbers left over. 1, -5, -3, and 15. That'll be 1. That gives me 5. -5 plus 5 is 0. Okay, that's cool. 5 times 0 is 0. Got it. Right here, this gives me -3. Now, that's going to give me -15 and 0. Everything worked out just like it should. So I'm out of zeros to use. So now I have r, c, x, x squared. So writing down my last polynomial factor, this one is going to be x squared. I can leave this off and say -3, and I want to set this factor equal to 0. Well, this one's quick. Move the 3, and I get x squared equals 3. Take the square root of both sides, and we get x equals plus or minus square root of 3. All done. Nothing else to do. All right, so you won't always get fractions. Sometimes you'll get radicals. Now for the last one. So for this one, we're going to do the same thing. So I have x to the 4th minus x to the 3rd minus 15x squared plus 23x plus 12. All right, so it looks like -4. That one's definitely between, so it's nothing I can use. And that one looks like it's around 3. So let's see what we got. -4 worked. Perfect. Don't see anything else. Now 3. So I know I can use -4 and 3. So x equals -4. I guess -4 is my favorite number when I made this lesson. And 3. Perfect. So now I can use -4. 4, 3, 2, 1, none. Everything's there. So 1, -1, -15, 23, and 12. All right, so drop that down. That's -4. That gives me -5. That gives me 20. That gives me 5. That gives me -20. That gives me 3. That's -12 and 0. Got it. Now for my next one, I have 3 on the outside. Using my numbers, 1, -5, 5, and 3. That's 1. That's going to be 3, -2, -6, -1, -3, and 0. Got it. Perfect. Now I'm out of zeros to use. So at this point, I can do r, c, x, x squared. Now I have this polynomial to solve. X squared minus 2x minus 1 equals 0. Now, if you try using the ABC method on this one, it's not going to work out for you. This is one that we're going to have to do something else on. So here you can either use the quadratic formula or you can complete the square. We've completed the square a lot, so I want to do the quadratic formula. And that's something that's going to help us out next time too quite a bit. So let's do the quadratic formula on this one. So I have x equals negative, parentheses for b, plus or minus square root, b squared minus 4 times ac, all divided by 2a. So filling in our numbers, my b is -2, my a is 1, and my c is -1. So reducing, I have 2 from a negative, plus or minus, divided by 2. And inside the square root, that's going to be 4 plus, right here, that's 4. That's going to be -4, so 8. So we wind up getting 8. Now 8 can reduce, so that's going to give me, that's 4 times 2. Square root of 4 is 2. Now I see I can divide these. So dividing those, I wind up getting 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1, square root. So my final answer on this one, I have -4, 3, 1 plus square root of 2, and then 1 minus square root of 2. And those are all 4 of the zeros that we found in the calculator. And we're done. There's nothing else to do on that. All right, so hopefully you've seen by this one, synthetic division is your friend. And for the main type of problem, you're going to look in the calculator for the zeros to divide by. Do it as many times as you can using those zeros. What's left over will either be linear, that you can solve really quickly, like we did on the first 2 problems, or you'll wind up with something that's quadratic that you can either factor, you can solve using the square root method, or you can solve using the quadratic formula, or completing the square, whichever you prefer. All right, that's it. So now you have a good idea on how you can find all of the real zeros for a polynomial. If you have any questions about this, please feel free to reach out and contact me. I'm always happy to help you out. Other than that, have a great rest of your day.